So hello guys, welcome back to this video, and in this video we are going to solve the next problem of our ongoing DP seat, which is the FRAZ DSA seat. So we are solving the 2D DP section, and we have solved two problems. And yeah, I am making this video after so long because I was busy with my office work. So I'm again starting to continue making videos for the further problems. So today we are going to solve the third problem of two-dimensional DP, which is partition equal subset sum. So let's open it. Yeah, it is already open. Okay, so we have the question partition equal subset sum. So the question states that given an integer array nums, return true if you can partition the array into two subsets such that the sum of elements in both subsets is equal or false otherwise. Okay, so basically you have one given array, and we have to partition this whole array into two subsets. So subset means we can pick any element and put it into either of the one bucket. Okay, so sequence doesn't matter, we can pick any element. So we have to just tell whether it is possible to make two subset of it, and the sum should be equal for the both subsets. So let's see this, how to solve this problem. So for that, let me share my iPad, and then I will explain you the solution. Okay, so yeah, my name is not Ritesh. So okay, now, so let's say if I am taking some example as let's say 1, 5, 15 and 5, 6, 9. So let's say this is our subarray, and we have to divide this subarray into two subsets of equal sum. Okay, so you can pick, let's say this is our one subset, this is our second subset. So here I can pick 1, 5 and 9, and here I can pick only 15. So here you can see the sum of both subset will be equal. But let's say if instead of this 9 there is some other element, let's say 8, is there any possibility? Is there any possibility? No, there is no possibility. So one thing, so if you just let's try to see some observations. So observations, let me write some observations. So one observation is, so we have to make the sum of both the subset equal. So we want equal subset, but sum of the whole array, if you sum both this if you try to find out the sum of both the subset, it will be equal to the sum of the elements of the whole array, right? So if you see that, so we have sum equals to sum of this array. This is our array, let's say some element e1, e2, e3, some en. So the sum of array is, let's say, some value x. So what is the possible case when you can split? If let's say if it is x, so it could be even, it could be odd. So if it is even, then you can, there is possibility to split into two parts. But if it is odd, let's say you have the sum of a whole array is, let's say, 13. Is there any possibility that you can split the sum of this array as half? No possibility, right? Because if you divide it, it will be 6 and 7. So either there is no way to make two subsets equal. So one thing you can directly see, that if sum of array is odd. Not possible. Not possible. So the only case for which it is possible when sum is even. And if the sum is even, we have also one case. So let's say sum is even, sum is x and this x is even. So if there is any possibility to divide, into the two parts, so we know that the sum of part 1 and sum of part 2 is equals to x by 2, right? So now our whole problem boils down to, if you closely look, our whole problem boils down to finding out any subset whose sum is x by 2. This x is the sum of whole array, right? So this will be only possible. So you just need to find out is there any subset available for which the sum of the element for that particular subset is x by 2. If it is possible, then the other way around is always true. Okay, now our main problem is just this. Okay, now so to solve this particular problem, we will use DP, because if you try to use recursion, so for every element you have two options: either take it in your subset or not take it in your subset. So if you try to see, the time complexity will be exponential. So I think you guys already know that stuff. So we are just focusing on how to solve this problem in bottom up way, directly dynamic programming bottom up approach. Okay, so we will define we already know that we are following some certain steps for solving DP problems. So let me first write that step. So steps. First, define DP state. Second, dry run on smaller cases. Third, derive transition state between smaller and bigger problem. So we will start with the first thing, which is defining our DP state. So I have already told you in the previous problems how we will define our DP state. So when we are solving two-dimensional problems, so basically why this is two-dimensional problem, first you have to think that, because here we have two parameters, we have some elements. When the idea is it is possible to solve by tracking the indexes of the elements, then we are using linear DP. But here, so let's say this is our array, let's say 5, 15, 1, 9. So this is, let's say this is our array. So for this is our indexes. So for simplicity, let me write it as one base index in 1, 2, 3, 4. So this is our indexes. So we know that for certain index, if we are just picking some certain value, so we have some certain elements, so we have to track that also. And for that certain element we have different possibility that. So if you are at some certain index, there is possibility that different sum is possible. So you have to, because in DP you have to maintain, when you are solving DP problems, what you are doing, you are trying to maintain the states of the problem. So you have to consider all possible states. So here you are at, if you are at 2, if you are at this index, so for this index we already know that if you take this 15 as a part of subset, so you have one possibility of sum as 15. If you not pick this 15, so one possibility is sum, but it is also possible that if you are not picking this 15 and you have picked this 5, so sum 5. It is possible that you are at 5 and you are at 2 and you have picked 5 and 15 both, so in that case sum is 20. So you know that if you are standing at this 2, so you have several possible options for sum also, so you have to keep track of the sum also. That's why here we are applying two-dimensional DP. So before solving any DP problems, try to think what are the possible states we have to maintain, which can be which can lead to generating the solution. If it is not possible with the less parameters, we will try to add more constraints. Okay, so now first here we can clearly see that we need at least 2 parameters as of now. If we need in future, we will consider it, but as of now we are not considering it. So let's say our DP of I and j. So what it means, we are considering only first I elements of the array and checking if making sum as j possible or not. Okay, now let's try to solve the smaller problems. This is our DP state. Now the second step is smaller problem. So in this above case only, let's say 5, 15, 1, 9. We have just one element. So we have, as of now, we have just 5. So we have one element 5. So what all are the possible sums? Right? What are all the possible sums? So one thing you notice that here a lot of possible options for sum is available, but is it really required? Because we know that we have to just check for the maximum sum as x by 2. So is this really required to just try make your possibility of sum as some big number? No, not required, because in that case you know that you have to just check for x by 2. So any value which is more than x by 2 not required. So the first thing before doing this, what you have to do is just try to find out the sum of whole array, like 9 plus 5, 14, 15 is 13. The sum of whole array is 13. Now x by 2 of this is 15. So we want any subset from this whole array whose sum is 15, right? So we want sum as 15. Now dp of 1 we are checking. So for dp of 1, right? 0 sum, 1 sum, 2 sum, 3, dp of 1, 4, dp of 1, 5, and similarly dp of 1, till 15. So we know that we have just one element, which is 5. So with this one element, what is the possible sum? So if you take this 5, if you take this 5, so you can make dp of 1 as 1, right? Means 5 is, with one element 5 is possible, but if you won't take this 5, then this is also possible, this is also possible, 0 is also possible, because you are not taking this 5. Any other possible? Can you make 1? No. 2? No. 3? No. 4? No. 15? No. Right? Now let's see if you have two elements. Okay, you are at 2, you are at second index, so dp of 2 1 0, dp of 2 1, dp of 2 2, now dp of 2 5, dp of 2 15, dp of 2 20. So let's say now you are at element number 15. Now you want to make sum 1. So is it possible, if you want to make sum 1, is it possible to if you take this element, is it possible to make sum 1? No, there is no possible. You cannot take that element. But if you can't take that element, then you will check if it is not possible to make with so let's say what I'm saying, dp of 2 0 I want to find out. So if you cannot take 15, so if you cannot take 15, you will just check, I'm not taking this number. So if I'm not taking this number, is it any possibility that you can make this sum 0 with the last elements from I minus 1, 0 to I till I minus 1? You will just check, right? So dp of 2 0 possible, because you can make with dp of 1 0, and you don't want to pick this current element, so you will just check, mark as 1. 1 you cannot make, either you pick, or if you pick, you cannot pick this element, because if you pick this element, it will always produce the sum more than equal to 15. So all the sum whose value is less than 15, you cannot consider this current element. If you cannot consider this current element, so you will just check, if I am not considering this current element, is it any possibility that I can make that particular sum with the previous last elements excluding the current element? You will just check. If you can make the sum from those number of elements, you can always make, right? So if you look at, you can make 5, you can make 15, you can make 20, because 20, if you can pick this 15, if you can pick this 15, so dp of 2 20. So if picking 15, if you pick this 15, what is remaining sum? So remaining sum is 5. So you will just think, if I can make this, if I can select this number, so can I make 5? Can I make 5 with the previous last 0 to I minus 1 elements, right? So you will just look at the previous table. Yeah, with one element I can make 5, and if I choose this 15, I can make 20. So for this also 1. For 15, if I select this 15, so how many remaining if you are choosing this 15, what is the remaining number you want to make sum as 15? 0. So you will just check, can I make 0 with previous elements excluding the current element. Yeah, you can make dp of 10 is true, so you can make. So this is the transition. So if you closely look that for any dp of ij, you have two options. Key, if I have just first I element and I want to make this sum j, so we can either pick this element, pick current element, or you can say ith element, or you cannot pick, not pick. So if you pick the current element, so dp of I, or so can you make the sum dp with I minus 1 element, and sum would be j minus nums of I. Means whatever the element at the current index, you are subtracting with the current sum, and you are checking that can you make the remaining sum with the remaining elements. So what does it means? I have just I minus 1 element, I want to make the j minus nums of I sum. Is it possible? Yes or no? It is not possible. Both options are available, right? But if you don't want to pick the ith element, so you just look at dp of I minus 1 and j, whole j, because you are not considering the current element. If you are not considering the current element, you have to just check, hey, can I make the same sum with the previous elements excluding the current element? And if you are able to make it, then yeah, definitely you got the solution. So this is the transition state of the your DP solution. So time complexity, if you look at the time complexity, so the time complexity will be order of n into max sum by 2. This is the sum of array, and space complexity is also order of n into max sum by 2. So this is the overall idea of the solution. I hope you get it. If you have any problem, I'm going to write the code. Just try to understand. You will get better understanding while writing the code. And even if you have any issue, just write down in the comment box. I will try to answer. And let's try to jump into writing code. Okay. So let's start. Now first I have to create one variable n for storing the size of this nums. Now what I will do, I will create one DP array of n plus 1. It's n also works, and here I want the maximum sum possible. So for that, what I will do, I will just find out sum. Sum would be accumulate nums dot begin, nums dot end, and 0, right? Now I know that it could be at max sum by 2, right? Now one more thing we have to do, we know that this sum, if it is odd, I will just return false, because I know that if it is odd, it is not possible to split into two arrays. But if it is even, for even sum we have to apply our dynamic programming approach. So first let me write what this DP means. So DP of IJ means if is it possible to make sum as j with just first I elements from the given array, right? Now one thing we know that if we have just one element, for one element what or or just not for one element. One thing we know that, let me first set mem set is equals to dp 0 and size of dp. I am resetting all the values of dp as 0. It means false. Okay, now first we know that for every I, we know that one thing is always true, that is dp of I and 0. It is always possible to make some 0, because I won't select any, I will not select any number. So in that case it is always possible to make some as 1. Now for the other values, what I will do, I will try for each index. For each index we have some option. J equals to 1 to, even let's say j equals to 0 to j less than equals to sum by 2 and j plus plus, right? Means here I am trying for all indexes, and for all indexes I am trying to check whether we can make these sums from 0 to sum by 2. So what I will do, we have option for picking the current element. So if I am picking, if the nums of I is less than equals to j, in that case only you pick. If your nums of I will be greater than j, you cannot pick. So if nums of I less than j, then dp of I and j would be same as dp of I minus 1 j minus nums of I, right? Is this looking good? But yeah, I will tell you what happened. Else dp of ij would be same as dp of I minus 1 j, right? Now here you can see you are accessing I minus 1 index. So for that you have to just do one more thing, that if I minus 1 greater than equals to 0, and here also else if I minus 1 greater than equals to 0, then only do this, right? So because anyway you are accessing this dp of ij equals to dp of I minus 1 j. Now you have almost completed solutions. Now we know that our dp is filled with all the valid answer. Now finally what we will do, we will just try to check that whether there is any possible answer for dp of n minus 1. Means I am trying to check that we have first n minus 1 elements, we have all elements, and can we make the sum by 2? Let's try to run it. So something we missed here. What we missed? Okay, we have started with 0 and j less than equals to sum by 2. If for nums of I j minus nums of I less than equals to j only, means j minus nums of I minus j. Yeah, nums of I if less than equals to j, then we can subtract nums of I from j. So I minus 1 greater than equals to 0. So it will always give some possible values. What is missed with this code? Nums of I j minus nums of I j is our sum. int sum by 2 out of bound for the type what is the sum? Is the sum calculating properly? Okay, let me check it. I will also teach how to debug fast. Run. Oh, there is some issue with this DP. Return false, right? DP of n sum by 2. Sum by 2 plus 1. Yeah. Yeah, right. Anything we missed with this? Definitely one more thing is always possible. dp of I and nums of I is always 1. Now let's try to submit it, because we know that it is always possible. If you just pick that particular element, for that particular element it is always true, so you have to consider that case also. Let's try to submit it and let's see whether it is accepting or not. Some runtime error, index 5 out of the bound. So yeah, why this error is coming? The reason is, yeah, I know that it will definitely come. The reason is, we have little bit optimized here. Like we do not want to store the whole sum, because we are only we just need the sum till sum by 2 only. So why to waste your storage and time? So instead of just putting its nums 0, if you will just check if nums of I less than equals to sum by 2, then only you will put this, right? So let's try to run it, because we don't want to store answers for any sum which is more than sum by 2. There is no need actually. So let's try to submit it, and probably it will be accepted. What is the reason why it is not accepted? Output is false. Why it is false? Why it is false? 2211. Something we missed. Here we did proper thing. I equals to 0. Still I have covered all the scenarios also. I know that this is 1 also. So here I am picking okay, yeah, right. So so if you are picking this and if you are not picking this, okay, so this will be or, this will be or. if you try to submit it, it will get accepted. Got it? Because we here what we did, I wrote that second statement in else block. That is not the case, because we discussed on the whiteboard for current index we have two different possibilities. We have these two both two possibilities, like either you can select that or you cannot select that, so you have to consider both cases. And I did or because I want, even in the even if any case it is giving true, then our answer will be true. Because if we are not selecting and we are able to make the particular sum, or if you are selecting you are able to make the particular sum, in both cases we will mark the answer as 1. Okay, so this is all about this video. And here you also saw the live debugging, how to solve the when you got some error, how to fix thing on the spot, right? So this is how you should think. You should try to write code, try to think the solution of the problem. Okay, so till then let's uh, take till then let's keep coding. And okay, see you in the next video with the next problem. Bye bye.